zum Abschluss ein Projekt aus Lausanne. Ja, bitte. Please, step forward. Don't be shy. This is Elodie Dahan. She will present the project OsmoBlue. And co-founder is here as well.
Yes.
So Anna is here. Yes, she exists. I've only seen her on pictures so far for about a year. And it was one of the conditions that you are allowed to be here, that she has to show face. And she really exists, so that's great. So, are you ready?
Yeah, I am.
Good, go.
So thank you very much for receiving me. I have the pleasure to present you OsmoBlue. So your trash bag is actually energy. If we burn it, it generates heat at high temperature that can be turned into electricity with a steam engine, or can provide heat to houses with district heating. But there is still a third of the energy contained in our trash bag that is lost in the form of low temperature heat below 100 degrees Celsius. And it's lost because today there is no technology available to turn that into valuable energy. At OsmoBlue, we want to turn this huge energy potential into electricity. So how can we do this? We are using the principle of osmosis. Osmosis is a natural phenomenon. When you put salt on a cucumber, for example, the water is drawn out of the cucumber because salt has the power to attract water. So we create a flow of water that can be used to actually turn a turbine and generate electricity. But after this process has been done, we have water molecules and salt molecules attached to each other. So if we want to repeat the process in a loop over and over again, we need to separate those two molecules. So how can we separate them to continue the process? We know that with high temperature heat, we can actually separate water from salt. If we boil the water will evaporate and we can separate these two molecules. But we don't have access to high temperature. We want only to use low temperature, below 100 degrees Celsius. So how can we separate them? Actually, we are developing a specific osmotic agent at OsmoBlue. I won't give you the recipe today, but I can say that it has a much higher osmotic power than salt, and it has very interesting thermal properties at low temperature, between 30 and 100 degrees Celsius. So with this technology, we can now make heat engines able to turn this low temperature into electricity. The potential is huge. It's not only in our trash bags and waste incinerators. You have all sorts of plants that have losses at low temperature. You have cement plants, paper and pulp plants, petrochemical and chemical plants. So it's a huge potential that can be today exploited with our OsmoBlue technology. If you take all the heat, industrial waste heat at low temperature today lost in Switzerland, we could power all the city of Basel. So this is the OsmoBlue technology. Thank you.
Thank you. Okay, first of all, congratulations to the nominee. Now, I have a question for you. Is it really working?
It's in progress. We validated part of the technology already, and now we've just assembled our prototype, and we are testing it these days.
So that's great. And where are you hiding?
Actually, OsmoBlue have some part of the team that lives in Barcelona. I live in Barcelona, and it's where the chemical development is taking part. And in Lausanne, so it's taking part the engineering.
Yeah. Okay, that's the reason. It's good to have you here. So, again, congratulations, and thank you very much for being here.